Coming up, launches.
Payloads.
Competitions.
Pluto.
And we're going to be talking about where we should explore in the solar system next. Stay tuned. Tomorrow begins right now. And welcome to Tomorrow, episode 9.04 for Saturday, February 6th, 2016. My name is Benjamin Higginbotham, and before we get started, a huge shout out to all of the patrons of Tomorrow who've helped to make this specific segment of this episode happen. These are the people who've contributed $10 or more to this episode. If you'd like to find out how you can help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. The cool thing about our crowdfunding campaign is it's a very fair system. It's whatever you think the shows are worth, that's what you can contribute. Now, let's go ahead and get started with some space news. I accidentally last week left out a launch, so we're going to put it into this week's show, and that is the Eutelsat 3B via a Proton. Man, that is a powerful engine. You hear it just like destroying that microphone. That happened Friday, January 29th, 2016 at 22:20 Coordinated Universal Time from the Baikonur Cosmodrome. It's the Eutelsat 3B is a broadcast satellite. It's going to send hundreds of channels across Europe. It's also going to link the surveillance satellites together and act as kind of a telemetry relay satellite for anything that they send up there. This is kind of equivalent to what the U.S. uses called the TDRS system, which is the Telemetry Data Satellite System. And it's going to allow you, when they've got spacecrafts up there, instead of having to beam the signal down and go through like plasma and like straight into ground stations, they'll be able to send the signal from the spacecraft up to these satellites that they're sending, so they'll actually have much broader range, and they'll be able to maintain communications with their spacecraft, satellite, whatever they may be sending up there. It's designed for a 15-year mission, and as an extra added bonus, it's also going to improve the link between the International Space Station and scientists on the ground. So a bunch of stuff happening on that particular bird that's going up there. That's pretty cool. Yep. All right. We also had on a LongMarch 3C the Beidou satellite launch. That is literally, wait, hang on, and that is all the more official coverage we got from China. So that was it. It was like 5 seconds, and then they just gave us a bunch of B-roll from the control center. It was like, thanks guys. However, that's actually a pretty cool animation. I thought the fire rendering on that was pretty neat. That's it. That's all you get. However, you can't hide stuff like that, and there was some non-official coverage that was taken, and we found this on YouTube of that exact same launch. Way cooler. Oh man, they are too close to that.
Is that like someone's house?
There are a bunch of children in the background, so I think, well, first off, yes, I think so. Secondly, I think they're near a school because of the number of children. I could be mistaken, I don't actually know that. But third, did you notice you saw the fire ignite and then just a couple seconds later you heard it?
Yeah.
They are way too close to that rocket.
Way too close.
Way too close to that rocket. But they got us really cool coverage, so thank you. That happened Monday, February 1st at 07:29 Coordinated Universal Time. This is the Beidou navigation satellite. This is basically part of the Chinese GPS system, essentially. And this particular system is going to test interconnections between all of the different satellites. So they'll be able to not just communicate back with the ground, but much like the previous satellite, be able to communicate between each other. This is going to grow their GPS system to help it grow to a worldwide system. It's the 21st payload for this, and they want to get this whole navigation system online by 2020. And they're going to join only 3 other nations that actually have this. The United States have GPS coverage right now. Russia has the GLONASS system, and which is still being built. I'm sorry, no, that's mostly built out. And then Europe's got Galileo, which is still being built. So congratulations to China for making that happen. There's actually a lot of GPS stuff happening.
Yeah,
because here's
here's
an Atlas V. Oh wait, Mike, were you waving at us and I missed it? Wait, we can't hear you. Hang on.
Sorry, that was my fault. Also, India has their EarNest system, the Indian navigational satellite system. So
I'm
they're way behind China, but they're getting there too. They I think they have regional GPS systems
They do.
for India and Pakistan. I don't know if there's any others, but
But I believe the other ones are worldwide systems. Isn't India just like over India?
Yes.
So
yeah,
I should have
like I
qualified.
said,
I
it's
should
a
have
regional
qualified.
system.
Yeah, I should have qualified that as a worldwide positioning system. So I'm not sure
They're
it
working
matters.
towards it. And other than them, there's no one else though.
Although
So
is Galileo worldwide yet? I'm not sure Galileo gets that quality. I mean, it's
I'm not
still
sure it
No,
is.
it's
it's
I'm
like
not sure,
delayed
though.
and like not moving quickly. So
Yeah, they're
there
just
you go.
getting like the first series of satellites up for that.
Yeah, absolutely. So speaking of GPS, how about a GPS 2F12 launch via an Atlas V?
3, 2, 1. RD-180 ignition. And we have liftoff of the United Launch Alliance Atlas V rocket carrying the 12th GPS 2F satellite for the United States Air Force.
This launched Friday,
Global
February 5th
Positioning
at
System.
13:38 Coordinated Universal Time from Space Launch Complex 41 in Cape Canaveral. This also, for the rocket itself, actually debuted an upgraded avionics package for the Atlas V, which had modernized and consolidated packages for the vehicle and updated software, according from a tweet from Tori Bruno. So that's pretty cool. I think that's part of the Cape's. The Cape is requiring autonomous flight termination systems now, so I assume that that's part of that particular package. This is the 12th and last GPS 2F satellite. There were 60 satellites launched from 1989 through today, which means that's right, there was like 27 years of the Block 2 GPS satellites. We're moving on to Block 3. Now, the Block 3 was originally supposed to launch in 2014. It actually hasn't launched at all yet. They're now targeting May of 2017 aboard a Delta IV, which is going to be pretty freaking awesome. Now, the Block 3 is going to have new ground stations and new satellites, so they're modernizing this system from, the 80s, the late 80s, I suppose. It's going to have additional navigation signals for both civilian and military use, which will also improve accuracy and availability to all users across the world, I would assume, but mostly here in the U.S. Generally, they try to give priority to the U.S. stuff.
Yeah.
All right, Space Mike, tell us about some updates on the Space Launch System.
That's right. So with the Space Launch System, they're going to be carrying 13 CubeSats on at least the first mission that'll have a test payload of the Orion capsule. And we actually have a video animation of that sort of deployment of these CubeSats. With this, on the first flight of NASA's new rocket, the first mission is going to be called Exploration Mission 1. And this is going to have a rare opportunity to send CubeSats into something other than low Earth orbit, where most other missions have been related to. And with this, they have several of these payloads that are already accounted for within different exploration programs within NASA. 7 of these CubeSats, in fact, are NASA CubeSats. And all 13 of these are 6-unit CubeSats, which are 6 single-unit CubeSats stacked together, which you'll see a little bit later on in this video. And they also have 3 of those CubeSats that are reserved for their international partners. They haven't finished negotiations with them yet as for what CubeSats and even which partners will be riding along on this first mission. But something else that is really cool about this is 3 more of the CubeSats that will be riding on this are being done in a competition style, and this is what they're calling the CubeQuest Challenge. This is part of NASA's Centennial Challenges, and they're actually offering prize money to winning teams who compete and essentially have spacecraft races in space and on the moon. And you can see here with the cryogenic interim upper stage, after the Orion spacecraft has deployed from the spacecraft, it is inside of this payload adapter where all of the CubeSat deployers are. And they'll be deploying each one one by one to send it into its different orbits. Not all of them will be going to the moon, which Exploration Mission 1 is a flyby around the moon and coming back to Earth. Some of these CubeSats will be going on to explore asteroids. And with the 3 CubeSats that will be done under the CubeQuest Challenge, some of them are to be doing goals for deep space communication and how to be able to find solutions to deep space survival, especially for small satellites. And around the moon, there's also other challenges there. What they want to focus on for lunar CubeSats is mainly propulsion and navigation for those small spacecraft while they're in lunar orbit. So this is a really interesting competition. It actually is producing in 3 phases. The first one is ground challenges that are going to be held every 6 months for at least the next couple of years. And anyone can participate in that, not just the space industry, but universities, as well as amateurs and makerspace enthusiasts. So this is a really cool challenge that was going to be done, and anyone can participate in. And winners of the ground challenges, the top 5 teams of different ground challenges that occur every 6 months, will be the ones considered to eventually fly on the first mission of the Space Launch System. And if they don't have a winning slot, they can still participate in the deep space competitions and the lunar competitions if they can get another ride to the moon somehow. So this is a really cool program, and I think it's going to hopefully inspire a lot of different progress, and we'll see some cool stuff from that. And if we can advance technology and make all the electronics even smaller, then we're going to be able to accomplish some really cool things with that. So anyway, speaking of competition and entertainment, I'm going to pass it back over to Carrie Ann.
So, as many people are very aware, the big game is going on this weekend, and if you're on the International Space Station and you want to participate or at least watch a little bit because you want to cheer on your favorite teams, how do you do that, right? Particularly, well, I mean, in the past there have been TV shows, there have been movies that have even premiered on the International Space Station. Live launches they can watch there. They actually have an HT projector and a 65-inch screen. But this one in particular represents a huge first for the United Kingdom and the British Broadcasting Corporation. Tim Peake, one of the first British astronaut in space, or in the International Space Station, I should say, was requesting to watch the Six Nations Rugby Championship game.
Really?
Yes.
Really?
The other big game.
That's a huge game. It incorporates England, France, Ireland, Italy, Scotland, and Wales.
They have the best view of any humans ever.
Yeah.
And they're like, I want to watch a sports game.
Well, and it's a really...
yeah.
Yes.
Apparently, I'm the only one that odd duck out here. I'm sorry.
Some
Continue.
people still like sports ball. It's kind of a thing.
Weird.
Sorry.
Sports ball.
Well, because astronauts are allowed to take up books and music and what have you, and then they are also allowed to request TV shows, and sometimes they request live TV shows. Anyway, it's really interesting. I think it's interesting. It's going to be uploaded with 25 megabits, is that right? Per second uplink. It actually has to go from the BBC, the British Broadcasting Corporation, over to ESA, the European Space Agency, who then has to beam it over to NASA in Houston, who then puts it up. Like,
there's an irony there in that they're actually closer to the satellites that are broadcasting that.
I thought it was hilarious. I thought that was really awesome. Anyway, so
I know that's not how that works, but it is ironic.
No, exactly.
It's
So
like seeing the signal just go.
I wish you could watch it kind of do all of that, right?
Well, I think the best part is it's probably
Really
they're probably
amazing.
using satellites to do that, right? So
Yeah.
if you were to visually look at the signal, it's probably passing by the space station, coming back down by the space, passing by the space station again,
Yes.
coming back down before it gets beamed back up to the space station.
I
It's
thought
like
that was hilarious.
going in and out, like weaving around the signal.
Anyway, for anyone who's a little bit concerned, the Six Nations Rugby Championship game is actually going on today, Saturday, while the Super Bowl here in the U.S. will be, of course, on Sunday. So there's no overlap there, no worries about one game interfering with the other.
What's the Super Bowl?
It's this other sports ball thing. They have to move the thing to the other thing, and then people get really excited about it.
Yay.
It's really funny, though, because there's a lot of cosplay, and the tickets are insane.
Yeah. They have like an oblate spheroid and they throw it. And sometimes they run with it. And every once in a while they kick it. And even though they only kick it a little bit, they call it foot.
That's
Yeah.
weird.
So, yeah.
And the field they play on is the International Standard of Measurement.
See, it's all very space related.
There you get a high five for that one. There you go. High five me. High five. There we go. Thanks. That was good. Oh, man. The control room is still laughing on that one.
Hey, Mike, how many space stations wide is that field?
One.
one
Space station's
one
bigger.
international space station.
Which way? Which way are you measuring it?
Yeah. It's,
All right, Jared, let's move it over to you, and I'd like you to do all your measurements in football fields from now on. Talk to me about some new science from Pluto.
Okay, well, one of the cool things about New Horizons is that because it's so far away and that data trickles back so slowly, it seems like every week a new bit of science is coming back.
What's New Horizons?
So New Horizons is the mission that we launched to Pluto back in January of 2006, which flew by Pluto on July 14th, 2015, last summer. And let's go ahead and take a look at the imagery that we've gotten back from it here. So that is Pluto in a false color over there, just to bring out some of the detail. And there is the heart that everybody remembers called Sputnik Planum. And after some recent research, scientists are confident that the left ventricle, the left side there of Sputnik Planum, is actually a massive impact basin, which is a relatively young 100 million years old. And that doesn't sound very young, but on geological timescales, it's sort of like looking at a 2-year-old right there. Now, they think that residual heat from that impact basin is still present underneath the ice there. And that ice is made out of nitrogen. And very cool, they've realized that nitrogen ice has a consistency like toothpaste. So you can imagine trying to walk around on it probably wouldn't be a very pleasant experience for most of us. Would it be minty? Potentially. It would definitely leave your boots feeling pretty fresh. Now, the heat...
This is a show.
Anyways, the heat is actually causing convection of that nitrogen ice very slowly, but a very rapid geological convection. So you can imagine some of that ice will well up and then go out and drop back down as it cools off. And then it will get heated again and well up and then drop back down as it cools off. So as we always like to say, it's kind of like if you're making oatmeal and you're boiling it in the water, and you notice the oatmeal will kind of make that little circular motion inside of the pot of water that you're making. Now, when they looked at the images, the much more high-resolution images like we were just showing you, these right here, they noticed that there's these hills out in the middle of the plane, and they were wondering, how do you get hills out in the middle of a plane? Well, they have discovered that those hills are made out of water ice, which is less dense than nitrogen ice, which means that if you put water ice on nitrogen ice, water ice will float on top of the nitrogen ice.
Cool.
So what's happening here is that as the nitrogen ice is going through its convection process, that water ice is actually being pulled out by the nitrogen ice into the middle of the planes there. And then it will reach a point where that nitrogen ice will drop back down, but because the water ice is less dense, it will just float right over the area where it convects at. So really cool, as we gave a good analogy for it. If with that oatmeal boiling, if you threw marshmallows in it, that's like what the water ice is doing. The marshmallows are staying on top as the oatmeal convects with it. So really just some awesome science happening out in the outer solar system that we had no idea would even be there. And that's what's so exciting about it.
Do they normally have marshmallows in oatmeal?
I don't know.
Is that a thing that you would
Sometimes,
If you'd like
actually,
to.
yeah.
That
I
seems
suppose.
gross.
You should give it a try
I've totally seen
in
that.
After Dark.
No,
Yeah.
no.
No, I agree.
Oh,
We
okay,
should.
no,
We're
no.
going to do that soon.
All right,
So glad you brought that up.
moving on, let's bring it back to Earth for some new developments there. Mike?
That's right. So the European Space Agency has signed a new deal with Sierra Nevada Corporation. They're investing money, about $36 million or 33 million euros, to help the development of the Dreamchaser space plane, now in its cargo variant. And what they're working on is what's called the International Berthing and Docking Adapter. This is different from the International Docking Adapter that has been built here from the United States. And that's going to be used on the cargo version of the Dreamchaser to be able to dock and berth with the space station if they're using that type of method for whatever mission they might need to do. And that also goes into what ports are available when. But anyway, that goes into a whole nother story. In any case, the European Space Agency has already been working with the Sierra Nevada Corporation on the Dreamchaser for several years. And up to this point, they've already invested about 20 million euros into its development. And at the time, they were looking at it more as a way of sending up crew and sending up astronauts to the International Space Station or other destinations. And what this new deal would lead to, and this whole thing came about because Sierra Nevada won a contract with the Commercial Resupply Services 2 contract. And because of that, they're investing this more money, And individual nations within Europe are looking at different opportunities of being able to use either their technology or investing in collaborations to have stuff flown on the Dreamchaser. And this could lead to even microgravity research and free flying versions of the Dreamchaser spaceplane to facilitate those sort of needs. And not only that, but they're also looking at different studies to fold the wings of the Dreamchaser, which they're already going to have to do anyway for the cargo version in order to fly on the Atlas V, so that they can fly the Dreamchaser also on the Ariane 5. And that would be able to enable a lot more stuff if Europe wants to utilize it and not interfere with any of NASA's developments with the Dreamchaser spaceplane. So this is really cool, especially the German Space Agency, the DLR. They really have been interested in the program before. And as of right now, they're not investing any more money into the Dreamchaser spaceplane because they kind of want to see how things develop. And especially if they do fly in space again, then they'll probably proceed at that point if it makes sense for both parties involved to have another sort of a project or collaboration between them, but could lead to some really cool things. And it just gets me more excited that all of this life has been breathed back into the Dreamchaser spaceplane. So I'm really looking forward to that, but that's just a really cool update that I thought that you guys would appreciate. So anyway, long before the European Space Agency even existed, Russia was the first in many areas. Right, Carrie-Ann?
It was. Ben, did you want to ask?
I have a question.
Okay.
Before we move on, you said that they would have to fold the wings of the Dreamchaser up for the Ariane 5. But my question is why, right? So the Dreamchaser shouldn't require ferrying or anything like that. So what does the width of the plane have to do with anything?
Well, actually, on the cargo variant of the Dreamchaser spaceplane, they actually would want to encapsulate it inside of the payload fairing of the Ariane 5. They might not necessarily have to fly it in that configuration on the Atlas V, but on Ariane 5, with how fast the Ariane 5 takes off, they don't want to screw with the aerodynamics of the Ariane 5 during takeoff if the Dreamchaser would be a payload with that. If they had it in the free flying form that you've seen pictures of on the Atlas V, where just the Dreamchaser is just right on top with a little payload adapter, that would mess with the aerodynamics and could even throw the rocket off. Even with all of their guidance and control, it could still throw the rocket off and mess everything up. So that's why they want to encapsulate it inside of a payload fairing to make sure that the aerodynamics wouldn't be messed up and they would have a successful mission.
Interesting. Awesome. Thank you. All right. Now, I'm sorry. Let's head it back over to Carrie-Ann. I didn't know. It didn't make any sense. Like, why are we folding the wings when we're just going to stick it on top of the rocket? That doesn't make any sense to me. So go ahead. So talk to me about Russia.
Well, I mean, so there's a new documentary coming out about cosmonauts and, quote, how Russia won the space race documentary, which is kind of interesting because I was born in America and I've grown up in America.
We went to the moon first.
And yeah, and so that's what a lot of people, I should say, in America particularly, that's how they feel. But this documentary is really looking at everything, the perspective from quote-unquote behind the Iron Curtain, if you will. It is also produced by the BBC. Apparently it was BBC heavy this week. And it looks at mostly during the first 8 years of the first decade, the many milestones that were won by Russia, such as first satellite, Sputnik, 4th of October 1957, the first creature, Laika, the dog, 3rd of November 1957, the first human, Yuri Gagarin, of course, 12th of April 1961, the first concurrent space flights by 2 cosmonauts, which I had actually no idea, didn't even think that was, I mean, obviously somebody had to do that first, right? The first woman, Valentina Tereshkova, which is 16th of June, 1963.
By like there was a long difference between the first woman there and the one in the U.S. It was
crazy pants.
20 years difference?
Yeah,
I mean, it was a long time.
Ridiculous. The first person to walk in space was Alexei Leonov, 18 of March, 1965. So between 57 and 65, Russia was just like hammering these firsts out like there was no problem. So the documentary looks to why and how Russia was able to accomplish all of these firsts in such a short amount of time. And I won't necessarily go into it because I want you to watch the documentary because I think it's really interesting. It also goes to point out that after some setbacks, because, of course, there were some deaths and some issues with some rockets and what have you, that they had found a brand new focus in looking into orbiting space laboratories and how that sort of helped not just move their program along, but how it also kind of brought into focus what other programs may or may not want to do moving on to the future, right? Because then, of course, NASA did theirs, and China is looking into, not China, why am I blanking?
Russia?
Yes. Well, but I mean, like this.
China had space station programs.
Okay,
too.
it
They're
is
doing-
China. I don't
Yeah.
know why I totally blanked on that. I apologize. Yeah. Anyway, so and how this huge effort to continue to do that, and so there's that. It actually aired. Somebody wrote in here the question of what was the air date. It actually aired on the 5th, which was yesterday, at least here in the U.S. But they are re-airing it, so you'd have to look it up. I apologize. I don't have the.
Would that be on the BBC?
Cool.
Yeah, originally produced by the BBC. It should be there.
Cool.
Excellent.
Awesome. Well, while it's fun to reflect on the past, we have some reflectors for the future.
Yes.
that are being
Reflectors?
reflected.
Really?
Reflect on the past.
I'm not
That's fine.
subscribed to that
I'll
pun.
take it.
That is
What?
too
No,
punny
no.
for me.
I'll take it because it's accurate in its terminology.
It is. I still don't like it.
That is correct.
All right. No, well, hang on. Give me one then.
No, it doesn't matter. I just don't like it. I'm not subscribing, period.
Well, you could use.
Unsubscribe.
All right. Well, then give me yours.
No, it doesn't matter. I don't have to prove myself. I just unsubscribe from that one. Thank you. Unfollow. Next.
Well,
You're one of those. You just thumbs down that on YouTube,
Yeah,
didn't
I
you?
did. Sorry.
well, I'm going to thumbs up this because the 18th and final segment of the primary mirror of the James Webb Space Telescope has been installed.
See, reflective. Get it?
Yes, it is because it's a reflector. Very good.
Boom. You're welcome, Internet.
So take a look at the actual assembly that they have done. You can see that on the bottom there in that hexagonal pattern, that is the primary mirror with that tubing there that holds up the secondary mirror, so the light hits the primary, gets bounced up to the secondary, and then back through the middle of that mirror into the instrumentation. Each of those hexagonal segments is 1.3 meters across. And that primary mirror is 6.5 meters across compared to Hubble's 2.4 meters. So it's big.
It's freaking huge. Actually, there's another image. I think it gives you a better idea of scale.
Yeah, take a
there
look
you
at this.
go. So you can actually see kind of. I mean, there's not a whole lot of stuff in there for context, but
Yeah, you've got the technicians in the back there.
yeah, but they're too far away for you to really get a good proper.
They are a little too far away. But yeah, just to give you an idea, it's gigantic. It's humongous. It's so humongous.
It's one unit of huge mungus.
Yes, it's ginormous.
How many football fields is that?
How many football fields is that? Actually, I think it's about I would say a ninth of a football field. Although when James Webb is in space and it's like unfurled and everything, because they literally have to like origami it to fit on the Ariane 5 it's going to launch on 2018. When it's finally unfolded and out, the entire assembly for James Webb is going to be about the size of a tennis court. So, which is just
That's not a standard unit of measurement.
that's
though.
huge. That's gigantic.
It is gigantic, though. James Webb. It is hard to comprehend how freakishly huge this thing is going to be.
And it shows you just how difficult it was to make this thing too, because nobody's ever attempted to make a space telescope this big before. So
Is that why it's so late and over budget?
yes. Also, it's in the infrared too, which means it has to be super cold in order for it to actually work. So that's another problem. You have to keep that huge area super cold, and that's another reason why it is so late and over budget, and it's the telescope that ate the budget. So
It's the telescope that ate the budget. So speaking of budgets, before we go into break, we did a show a little while back. This is not in my show notes at all, so I'm just doing this from memory. We did one on escape dynamics, and it was really interesting. It was one of those shows where it's microwave propulsion. And so instead of using chemical rockets, you use microwaves to propel your vehicle. And at least I assume a lot of our viewers as well, kind of went into that going, that's not a thing. This isn't real. And then you start talking to them and you realize they actually have real hardware and they actually are doing this with small models right now. And they really have this well thought out. And you go, actually, this could be a thing. Not anymore. So escape dynamics is basically shut down operations. When you really peel back the layers, it sounds like they were unable to find additional investors to keep moving forward, which was really sad. I was really excited for what they were doing. I thought it was fantastic stuff. It doesn't mean that technology will never work or no one else will pick up that particular torch. But yeah, so escape dynamics, as we interviewed them, I think it was last year, is no more. So there you go. How's that before we go into break? Speaking of, we're going to take a quick break. When we come back, our main topic of where we should explore in the solar system. So stay tuned. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. Nothing in her way will keep her from her destination, 'cause she's fine.
So Jared just noticed that it said classified on the bottom. He's giggling over here to my right. Yeah, you can hear him giggling. In addition, it is hex encoded. So that actually is real verbiage underneath there.
Really?
So if you sit there and type it into a hex decoder, you'll actually figure out what it says.
Oh my gosh.
I'd like to thank all the patrons of Tomorrow who helped make this specific segment of this episode happen. These are the producers of Tomorrow. They've contributed $5 or more to this specific episode. We are a crowdfunded show. Every single dollar helps. Head on over to patreon.com/TMROs to help figure out how you can help crowdfund the show. All right. And you know what I forgot to do last episode, which was a big, big no-no? I introduced myself. And then I didn't introduce anyone else. So to my right is Jared. He is our
Hi.
He is our science/stars guy.
Yeah.
There you go. We've got Space Mike. He is our rocketry/awesome stuff guy. And over here we've got my beautiful, lovely, wonderful, and talented wife, Carrie Ann. And she's very excited to be here. You can tell. All right, let's go ahead and get into our main topic, which is where we should explore in our solar system next, right? We just sent New Horizons to Pluto. We've now explored all of the known planets in our solar system because Pluto's still a planet.
Of course.
You know, actually, is there ever a possibility that Pluto could be reclassified? Because what classifies a planet is completely made up by what we decide classifies a planet. So could we go, you know, we're going to change the classification of planet to make more sense?
There's a lot of, I was going to say, there's just to write on that a little bit, there's a lot of discussion that when we are able to actually resolve exoplanets and start to look at them, that we are going to have to completely rethink what actually classifies a planet as a planet. So for now, that's how it will remain. And sometime in the future, hopefully in the next 20 to 30 years, once we start actually seeing exoplanets and we can determine their composition and what they're made out of, then we will go back and we'll have to literally redo it again.
So it's completely possible Earth will be declassified as a planet.
No. No.
So we just explored the planet Pluto. I say that just to irk you, and it doesn't work.
It's okay, because, you know,
If
I,
Dr. Neil deGrasse Tyson was
still
here.
a planet.
as a scientist, I hear people saying wrong things all the time, so, you know, it doesn't bother me.
All right,
so.
all right. We've got Planet X, Planet 10, Planet 9,
yeah.
whatever. Which we haven't actually proven, by the way. I mean, we mathematically, we're like, there should be something there with math, but we haven't found it. Right?
Yeah.
There's no visual evidence.
They're hunting for it.
They're hunting for it, yep.
They are doing the groundwork for that.
So I assume if we find that, that's an obvious next choice. But where else should we go into the solar system?
I have always thought that we should definitely go out into the outer solar system. Because if you look at places like Uranus and Neptune, we've only had Voyager 2 go past those two planets. So we've literally only had just one vehicle go past them. That's it, with 1970s capable instrumentation as well. So not exactly the best stuff. Since then, we've used Hubble to do most of our observations of that, and that's expanded our understandings of it. But I would really love to see a mission where we go to either Uranus or Neptune and not just zip past it. I'd like to go in orbit around it.
Would you do the same with
Yeah,
Pluto?
have a Cassini-class probe going in orbit around both of those gas giants.
Yeah, it's actually one of the decadal surveys, one of the priority missions. I believe it was number 3 on that list of 10, where the scientists get together every decade and they figure out what missions they want to do. And number 3 was a Uranus or Neptune orbiter, basically like Space Mike was saying, a Cassini mission with multiple atmospheric probes and things like that.
Why don't we just have permanent orbiting spacecraft around all of the known planets in our solar system?
Ooh, that's expensive.
We're trying.
So yeah, we are.
Yeah. I mean, but why? But it doesn't have to just be the U.S. that picks up the tab, right? I mean,
Yeah, that's true.
U.S. can take 2, ESA can take 2, China can take 2, India can take 2. Boom, you know, we're almost there.
Yeah, that's a pretty cool way to work about it. I mean, especially with international collaboration. I mean, with the upcoming mission to Europa that the Jet Propulsion Laboratory is working on, they've now got the collaboration of the European Space Agency saying, "Hey, we see you have some extra mass capability. Can we put a lander on there that allows us to do that?" So, so the will is there to do it. We just have to find the right partners to do it, I suppose. That's pretty cool.
And I think that there is a consensus and there is a lot of agreement between the international partners. I mean, for example, right now, at Venus, Japan is the only country that has an orbiter there. We did have an orbiter there that is no longer functional. I believe it entered the atmosphere and burned up, but I can't
Venus
remember.
Express did last year.
Yeah, Venus Express. And if the Japanese orbiter had gotten there in time, both of those satellites would have worked in concert to do Venus exploration. So there is already a lot of deals. Just sometimes things don't work out the way they hope. But even at Mars right now, we're collaborating with the Indians. We're getting a lot of the info from their orbiter, and I believe that we've even helped to have some sort of data links between all of the different orbiters at Mars, even though they have their own system. We're allowing them to kind of piggyback on all of our satellites so that we can remain in communication with all of them. So that cooperation is already there, but I guess what we're trying to get at is that how do we deepen and further that cooperation to have even more cool stuff?
Yeah, I also just want to say, too, that sometimes places are just really hard to get to. Like Mercury is one of those places where it's so deep into the gravity well of the sun that you basically have to slam on the brakes all the way to get to Mercury. Or if you just coast on the way to Mercury, you're going to zip right past and then literally get flung into a potential orbit out of the solar system with that there. So there's some places where it's just so difficult to do it, period, with that.
But not impossible.
Not impossible, but you have to be willing to be very patient. Because Messenger, the mission that NASA sent to Mercury, launched in 2004, and it didn't get there till 2011, simply because of the fact that in order to get to Mercury and to get into orbit around it, it had to fly by Venus multiple times, Mercury multiple times, and it just had to gently get itself into there.
But things are changing now, right? With the Space Launch System, you can do more of a direct route to a lot of these things. So will that help enable solar system exploration once we have the Space Launch System running?
Yeah, a big rocket is obviously going to be very helpful in doing things like that. Also, sort of technological investment that we've done over the past decade with like the NASA's Dawn mission using ion propulsion for that would definitely be extremely helpful. Also, looking forward to Exploration Mission 1, there's going to be a few proof of concept CubeSats there that will actually use solar sails in order to allow them to get into their orbits near and around the moon. So that's going to help out too with that. And there's also this idea of maybe doing what was it called? Interplanetary buckshot, where you literally launch like 1,000 CubeSats, one with an instrument each, and you fire it off at whatever target you're going to do, and you use that as your method to study, like a huge in mass sort of crash into your object in order to study it kind of thing.
That's pretty cool. What would we learn from all of this, right? I mean, we've sent crafts to basically every object that we know in the solar system now. Well, that's not true. That's not true. Every planetary body in the solar system we have now. So what more could we... Why do this, I guess, is what I'm getting at. What's the point?
Well, I suppose if you had told everybody everything that we knew about Pluto at the time before New Horizons flew past it, you could have been pretty confident that we would have known everything there was to know about Pluto. But as we flew past or started to approach it, and started taking better and better images, we just kept having our preconceived notions of it struck down. It seemed everywhere that we had. And it ended up turning out to be this incredibly complex world at a place that we had no idea this kind of complexity could even happen. So now comes the big question, which is that how did that even happen to begin with? And we have to sort of go back and rethink the sciences that allow us to understand how these planets form and other things like that. So when we study the solar system, we kind of end up studying ourselves. When we look out and we explore and we take in the data and we try to answer those questions, we're also answering the questions about ourselves as well. Like, how did Earth get here as well? And why would that be important for the formation of Earth? Would that potentially have an effect on the formation of life here on Earth? And then when we go start exploring potentially other exoplanets, initially with telescopes, probably for quite a long time, unfortunately, we'll have a better idea of what we should actually look for. And then, of course, I'm sure that when we start doing that, we're going to get our preconceived notions destroyed on that as well. Because I think one of the great things about exploring the solar system is that every time we go out, we have these ideas of what we expect to be there, and it ends up being not necessarily completely different, but there's a lot of things that we weren't expecting to be there, and they end up bringing in more questions than answers with that.
So if we don't, I mean, we have our set of expectations, which is going to dictate what we put on the spacecraft, right, from an instrumentation standpoint.
Yes.
And then we get there and we go, huh, that's not what we expected. Well, doesn't that mean that we need to be essentially constantly sending new spacecraft with different instrumentation to these sites, to these locations throughout our own solar system, so that, because, you know, now we've got this set of data and we didn't expect that. Now we need a new set of data with a new set of parameters. Is that a thing we would be able to do using current technology? Or is it just so I mean, you mentioned it's so expensive just to send one craft to each planet in the solar system. Can we even send multiple craft to these planets, or is that not realistic?
Well, it would obviously be a planetary scientist's dream in order to have 2 spacecraft with different types of instrumentation that would work well with each other in order to do that. But I guess the thing that we do is you miniaturize the instrumentation as best you can so that you can carry as much as you can to a target that you may be going to. But ultimately, somewhere like Mars, where it has so many different orbiters right now, and on the surface too, where we're able to compare what's actually happening on the surface with the data that we're getting on orbit. That's sort of a great model for what I wish we would be able to do. It's just like we always say, it's the big budget question: is do you actually have the monetary ability to allow yourself to perform something like that? And I really think that we should. But of course, I think that the monetary argument is almost a whole other subject for another show in and of itself.
Well, I'll do one other subject that is definitely for another show that I'm going to throw at you really quickly. Humans or robots, right? We're talking about sending essentially robots to every to every planetary body in the solar system. Why not just send humans? I mean, the amount of data that a human can gather is substantially greater than that of what a robot can do today.
Yeah, there's a joke often said at JPL, which is that a human geologist could do in 15 minutes the collective work that all of the rovers have done over the past 2 decades on the surface of Mars.
Which I think is exaggerating a bit.
A little bit.
But not a lot.
Yeah,
right? I mean, a human could pick up the dead rovers that are sitting down there and, you know.
Yeah. Well, the Martian showed us that, you know, you could rework everything and make it communicate after sitting there for
That's how it
decades
works.
dead.
That's how that technology works, just so you know.
Yeah, just in case you ever happen to be
on Mars.
Just
dust off the solar panels, it'll power right back up.
Yeah,
just move the red wire to the blue wire. You're done.
Obviously. I feel like the problem with humans is that they require so much. You know, you got to keep a human
Expensive
alive.
keeping humans alive.
Yeah, very expensive. You have to keep them alive, you have to keep them entertained, and you have to keep them safe. So those are your 3 primary
I like how
things.
entertainment came before safety.
Well, I mean, you don't want everybody to kind of lose it.
That ties
on the way.
into the
He's
safety.
doing it in alphabetical order.
Yeah, thank you, Carrie Ann. And sending humans to Jupiter would require an incredible vehicle to do that. I can't even imagine how many Space Launch System launches it would take just to get a human vehicle up there.
And then to land on the surface of Jupiter.
Well,
The gas giant.
I would imagine you'd probably go to one of the moons. I would probably pick Ganymede just because it's out of that huge radiation belt around Jupiter that likes to fry the spacecraft that have to end up going
God, imagine
through
the
it.
view
So
from there.
That's got to be
It's
awesome.
gotta be epic. I'd do the show from there.
Yeah,
What's the speed of light delay from there?
It's, I believe, about an hour and a half, roughly.
So if you guys think that we're latent right now at about 15 seconds, imagine an hour and a half delay every time you enter something in the chat room before we actually get to see it. And then it's another hour and a half before you'll hear our response.
Yeah.
That would be an awkward show.
That would be a very awkward show.
So would you send, in addition to sending probes around the planets, would you also go around the moons as well?
Yes, absolutely.
All of them. If
Yeah.
you had unlimited budget, you'd just send something to everywhere and just have
I
it
would
orbit.
send something to everything. I would send, in Jupiter's case, I would send an individual probe to the 4 big Galilean moons. I'd also send a probe to the Trojan asteroids that are orbiting in front of Jupiter to study those, so we could see, what was happening in and around Jupiter during the formation of the solar system. That's what those asteroids could tell us about that there. So there's literally just an infinite amount of possibilities that you could do with exploration of the solar system. I mean, we could just straight launch a probe as fast as we can out of the solar system just to study how the sun interacts with the area around it in the Milky Way. I mean, we could do something like that. That would be an awesome mission to be able to do something.
Can't we
like
kind of do that with Voyager 1 too, right?
We are doing that with Voyager 1 and 2 right now. So, and we're gonna
with their 1970s technology.
Yeah, that's true, and also with their nuclear batteries that are very slowly losing energy, and we're only going to have them for about another decade. So
That's an interesting point. Although they're going to continue moving throughout the solar system.
oh yeah, they're just going to keep going.
Keep going until they run into something, essentially.
Yeah.
Cool. So what do you think, the viewers of tomorrow? Where should we be exploring in the solar system next? Actually, I'd like to tack onto that as well. Should it be human exploration or robotic? I think the perfect solution is a little bit of both. So where would you send the robots, and where would you send the humans, and why? And what would you like to gather from the solar system? What kind of core information do you want to see out there?
Yeah.
What kind of sensors would you put on the vehicle? How would you design our next exploration system? Leave your comments on YouTube, Facebook, Reddit, wherever you want, all over the web. We'd love to bring them back into the show. Speaking of, we're going to take a quick break, and when we come back, comments from our last show. So stay tuned. We'll be right back.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with some expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving, 'cause her heat keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And welcome back to tomorrow. Now, before we get on to the comments from our last week's show, I did want to give a huge shout out to all of the patrons of tomorrow who've helped to make this specific segment of this episode happen. These are the people who've contributed $2.50 or more. These are our Patreon Plus subscribers. And after this show, we'll be doing After Dark, and they'll get a copy of that as soon as it's made available online. But wait, there's more. We've also got our patrons. These are people who've contributed 1 penny. That's right, as little as 1 penny, and you get your name in the show as a thank you for helping us out. You also get access to what are going to become our mostly monthly Google Hangouts. I'm calling them Google Hangouts, but they'll just be using the same tech we use now. And you can find more information on that on patreon.com/TMRO. And as a reminder for the community, we're going to be starting our first of our kind of Hangout sessions the last Sunday in February. So, and the way it will work, it will be the last Sunday of each month is when we're going to do our Hangouts. And they will be shows related to the show itself, right? So we'll be talking about the future of tomorrow, what we're planning, what's going on in this crazy head of mine. Stuff like that. If you want a preview of that beforehand, all of our Premier subscribers get access to the Citizens channel on Slack, which is
Pretty cool.
a thing. It is a thing. You definitely get access into my brain. You get to see like some of the new chat room stuff that's going on, things like that.
Yeah.
So all right, let's go ahead and get started with some comments from last week. So let's hear. We've called you Comment Lord before, and then we called you Mistress of the Messages. So this week, I think we're going to call you, it was suggested, and I think this is a good one, we'll call you Capcom this week. I thought that was a pretty good. So Capcom, what's our first comment? Our comment, Capcom.
Wow.
Yeah. Wow. Alliteration is I like alliteration.
Amazing
All right,
alliteration.
amazing alliteration. Comment, Capcom.
This one comes from Fabio Milan off of YouTube. Space travel. I can't talk. Let's try that one more time.
Capcom, you let me down.
Yeah, well, you should talk.
Come in, Capcom.
Space travel will be safe when we are able to retire chemical rockets. Maybe when we can use electrical ion engine as powerful as a chemical engine, or maybe if we could make those technologies to transmit power to the engine work.
So
What?
to make the engine work, I think there's a missing word
Okay,
there.
sorry.
I just copy him verbatim from.
Yeah, sorry, and
I
I
don't really tweak 'em.
must have. Yeah, sorry.
Yeah, so I think Carrie Encom's Dad Dog says that's pretty good too. We maybe use that next week. So I'm not sure. Yeah, so chemical rockets certainly adds to the dangerousness of it because it's like 95% fuel and 5% everything else. Now, somewhere between 90 and 95%, and so there's just so much of a chance of the fuel having a we'll call it a unexpected combustion event, an unexpected combustion event. No, I'm not even going to try to say it again. Apparently, I can't say it.
Easy for you to say.
No kidding.
Yeah.
Holy, right? It's contagious.
Sorry.
But I'm not convinced that just being a chemical rocket is what makes it dangerous. The speeds involved are crazy, right? 17,500 miles per hour, 22,000 kilometers per hour for orbit, right? It's kind of hard to comprehend how fast that is.
Yeah.
It's very, and just even a little itty bitty thing coming into contact with your vehicle, like just someone left a screw outside the International Space Station, and it comes in contact with you at a 17,500 mile per hour velocity, assuming there's a difference in velocity there. That's going to rip right through you, right? I mean, it's just going to kaboom right through your vehicle. So I think there's a lot more than just being a chemical rocket that makes it unsafe. Hopefully we can find things that will help to make it safer. Radiation is another thing that makes it unsafe. There are some interesting ideas with using magnets and magnetizing the vehicle, kind of creating a faux magnetosphere around the vehicle almost.
Yeah.
But none of that's real today.
Yeah,
So,
a lot of those also require you to operate in a vacuum as well. So, like an ion engine, you can't really run an ion engine here in the atmosphere, so it'd be a little difficult.
I mean, you can
to
run
do
it, it's
that.
just not going to do anything.
Yeah, it's a good way to say it. Yeah, the
turn it on,
You
but-
can just run the xenon through it, and you can watch the xenon outgas out the back end.
And
of
it'll
it.
be
So,
bright.
yeah,
It'll be bright.
It'll be pretty, but
Yeah.
it won't move you anywhere. So.
Yeah, that's not to say there isn't another method. It's just that I haven't seen, with the exception of like Escape Dynamics doing something interesting, which is why I'm really sad that they're not doing it anymore.
Yeah.
I just don't see another technology that will get us out of Earth's gravity well. Now, once we're out of Earth's gravity well and in space, we have a few options. But while we're here on Earth, the options are much more restricted.
Yeah.
All right, moving along. Capcom, what's up next?
The next one comes from, I believe it's Glacius Blue off of Reddit. It says, I think spaceflight can be safe even with chemical propulsion, but it requires usability so you can actually examine components. Much higher launch cadence to get more data and more stable rocket fleet than have hundreds of launches with the same rocket configuration. Rather than SpaceX constant upgrades and other companies multiple configurations, and they also upgrade now and then.
Basically, the idea being that bring up your launch cadence, upgrade your vehicles constantly
Yeah.
based on the data that you learned. And Mike, did you catch the comment that SpaceX made recently about their booster 1019 refire? No. Oh, he's muted. All right, that's all right. Yeah, but there is data to be gleaned off of vehicles that you get back, and you can make them then safer, and that helps a lot. Again, we're talking about huge speeds and huge amounts of fuels, but
Energies out the
energies,
wazoo.
yeah.
It's
But
just-
I certainly bringing back the vehicle, studying it, learning where its weak points are that maybe you didn't anticipate will absolutely help a lot. All right, who's up next?
Next one comes from Kelly Starks off of Facebook.
Ooh.
Yeah. Is there such a thing as safe air travel, sea travel, bathtubs? Answers not unless you're careful.
Yeah. So right. There is no method of safe transportation.
No.
You could walk and accidentally die.
Breathing is dangerous.
Breathing is dangerous. Yes, all of there's no such thing as safety, and the idea that everything is safe is just the universe is trying to kill you as best it can. Every opportunity it has,
is.
it wants to kill you.
It really is.
So yeah, there's no such thing as anything being safe, essentially. All right, Capcom.
Next one comes from Scott Rankine, off of YouTube. Says, the best comparable metric would be the development curve of the aircraft industry. Based on flight rates and vehicle evolution, it's not unreasonable to say that our current experimental state-of-the-art corresponds to around 1911, when the first official airmail flights occurred in American and British-controlled India.
So, all right, I'm going to throw this back to the TMRO crew here. We do this a lot. We compare rocketry to the infancy of air travel, right? When air travel first came out, it wasn't very safe. Is that actually a fair comparison?
I think so. I mean, I might push it like a little bit forward, almost to the 1920s, but yeah, I think we are still in that kind of experimental phase before it became something a lot more common and routine.
But we've had it for so many years, well over 50 years now. Why is it still experimental? Go ahead, Dada.
because we're still delivering mail and not people.
But we deliver people. We have people on the International Space Station right now.
We deliver very, very highly trained individuals to a location to do a job. We're not doing commercial flights to go from one place to another. We're not putting a bunch of people inside of a tin can like a TWA flight and moving them over to their destination for a vacation.
So is that what's going to change everything? Is moving massive amounts of untrained people? Is that what's going right?
Well, if you're making the comparison to the airmail and the infancy of air travel, I think when you start to get into commercial flights for transportation of people from one place to another, rather than and don't even start with your argument about transportation as being from one place to another, Ben. These people are going to a place to do a job for the people that put them in the airplane. When I can walk up to SpaceX's Hawthorne office and say, hey, I want to buy a spacecraft ticket to the moon, then we're at where you can now walk up to American Airlines counter at LAX and say, hey, I want to go to Florida.
God, are they going to lose their luggage there too? Go ahead, Space Mike. Space Mike, I think did you have a comment?
Yeah. With the airline industry, there was that small time period when it was still such a very new thing and the first kind of passenger planes appeared. And I mean, I think the first big ones, could only have like 12 passengers on board. But that was a big deal, and it was very much a luxury thing and very expensive at the time. So I feel like we're just entering that sort of comparable stage with all these different companies coming out that may have space tourism. And even that is just, into suborbital. That's pretty much like taking a plane ride like at the fair or something like that, where you only get to fly for 5 minutes and then you come right back to where you took off from. So I feel like it's just barely entering that stage in the whole airline comparison.
What do you think, Carrie Ann?
I guess the other way to put it is, what else are you going to compare it to?
That's fair, right? You do need it. We like to be able to look at things with, something we already know. It's hard to compare to something you don't know, or, putting it in its own category. We like to categorize things and compare and contrast them. So yeah, is there actually? That's a really great point. Is there a better comparison? Because we keep comparing it to air travel, which is what I'm bringing up. Is it going to be? Is it actually like that as a fair comparison? Is there something that is a better comparison to air travel? Right? Because you can build your own airplane if you wanted to right now.
Yeah, you could.
Although you can build your own rocket. I mean, it's quite a bit more specialized, but you could.
Mm-hmm. Yeah.
Sorta. I mean, you could. So, go ahead, Doug.
I guess you could.
Copenhagen suborbitals did.
Yeah. Perfect. Copenhagen, Mike.
I completely lost my train of thought.
You're welcome.
You mean you lost your rocket of thought?
Yes.
No,
The other
you know what? I'm not
comparison,
picking that one up.
The other comparison is like to like 1400s, 1500s ocean exploring and very, very, very expensive exploration voyages.
That feels
That's
like it
a
might
good
almost be a better comparison. But it's harder to relate, back to Carrie Ann's point, it's really hard to relate to that, though.
Yeah.
And we can relate to air travel. We understand that in a modern civilization. I don't understand 1800s sea travel.
I think when we start colonizing places, it's going to be more like, landing in the New World in the 17th century. So, but that's a bit away. So.
All right, we've harped on this for too long. So
Yes.
Capcom, let's move us along. I thought it was an interesting topic, and I realized it could have been a main topic for a show, but I just actually, much to that, leave your comments on that too on all of our channel. Yeah, just
Tell us everything.
Keep talking to us, people. All right, what's up? What's up next, Capcom?
I have absolutely no idea how to say this name, so I apologize. Hopefully I do not
All right,
slaughter
Does
it.
anyone in tomorrow have any idea how to say this?
No.
Mike?
Saturnainen.
Yeah, and then
No, that's
Yixi?
my guess. I have no idea how the last name.
So we apologize. We do not know how to pronounce your name, but if you want, put a pronunciation guide in, and we'll try to figure it out. All right.
Yeah,
Go to it, Dada.
I was kind of okay on the Saturnanian. I don't know if it's YXC or not, but off of YouTube, says, thanks for uploading. I'm starting to consider donating to your amazing show.
So I brought that in. Yeah, I mean, cool. Thank you. Awesome.
Thank you.
Thank you.
I've actually seen this a few times, and people referencing it as donating. We actually do give you rewards at different levels, so we give you something in return. So I don't like to look at it as a donation. Now, every dollar, every penny helps, but you do get stuff in return. So it's kind of the same as if you buy like an episode of something on your Apple TV or something like that. You're paying for it. It's not a donation to Apple. You're paying for that media. The big difference is you don't actually have to buy us. We will let you watch the episode for free because we want to get in front of as many people as possible and get as many people as possible excited about human exploration of the cosmos. Now, robotic exploration is cool too. We
Yes.
need them both, but the really exciting stuff, the thing that's really going to push humanity forward, is getting off of this planet. So we want to get as many people excited about that as possible, so we give you the show for free. But if you want a few extra perks, get your name in the show, get access to those hangouts, you want to get access to After Dark early, get some things. It's not really a donation. It's you actually are contributing to the show, but you're getting something in return. So I just want to point that out because more than one person has said donation, and it's not bad. I understand where it comes from, but
Thank you, though.
yeah, oh, of course, absolutely,
you.
thank you. Yeah, we couldn't do this without you. And
Yeah.
I'll save that topic for our hangout. But yeah, there was a point not that long ago where we almost weren't going to be able to continue. So all right, and finally, Capcom.
Yes, this one comes from Mac Malakoi off of Twitter, actually. It says, tomorrow, I was listening to a space show and one of the listeners mentioned your Halloween episode. Flow costume wins. Hashtag tomorrow, hashtag comment lord.
So I will say, I enjoyed being Ron Burgundy, but your flow was amazing.
Thank you.
That
Yes, it was.
freaking fantastic. So, yeah, and if anyone knows what episode of the space show that was and approximately what time it happened in the space show, I would love to listen to that because I like to hear the kind of the cross space marketing
that would be
stuff. I think
awesome.
it'd be. I'll ask, what is a flow costume? If someone in the chat room has a picture or screenshot of it, we'll bring it up after dark. All right, that's our show for this week. I'd like to thank everyone so much for watching. After Dark is up next. If you're a Patreon Plus subscriber or above, you will get access to After Dark immediately. If you're watching live, you'll be able to watch it live with us. Everyone else, After Dark will be available in about a few weeks. And thank you so much for watching. We'll see you next week.
Thanks. Bye.
Cut him off.